Hey engineers, and welcome to Unit 3, which is computer programming and robotics. So we're going to be using a programmable microcontroller to make motors spin, make servos move, make lights flash, and so on. And we're going to do that with a lot of sensors. So I'm going to give you a little bit of an intro today. What is a microcontroller? How do I hook things up to it? How do I code it? And that's going to be what we're going to do. Like, I'll give you an intro. I'll physically show it to you, give you some pitfalls that I've seen in the past, and then teach you how to actually do your first code. So let's get started. Maybe you've heard of an Arduino before or a Raspberry Pi. Those are programmable microcontrollers. Maybe not Raspberry Pis, but Arduinos are. But this is the programmable microcontroller that we're going to be using, and I affectionately call it the Cortex, and that's its given name. But really, if you were to pull this case off, it would be kind of the exact same thing as an Arduino. It's just a made for VEX programmable microcontroller, and it's named the Cortex because it's like your brain, the cortex of your brain. It's the thing that makes decisions and tells your motors and your arms and everything which way to move. This Cortex, if you look at it, there's an on-off switch you'll see, I think over on this side. There's a place for your battery. There's ports for network cables. If you flip it around, well, let me show you your battery. There's a couple different styles of batteries, and you need a battery with this because your motors are going to pull from this and your light bulbs or whatever. So your battery plugs in like that. One of the pitfalls of this is people, when they unplug their battery, they just pull, and you're going to pull these wires away from that harness. I want you to always, number one, pull from the harness when you undo it, and sometimes it's really sticky. There's like a latching system, and if that doesn't work for you, I want you to grab a flat-bladed screwdriver and get in between here and then pry to get those apart. Don't ever pull on your wires to get them off. Just pry at the harness. Really important. Number two, these things will interface with your computer, so then you will end up plugging this in to your laptop. You guys are all going to get laptops. On this Cortex, you'll see a USB, and it's kind of tricky. When you look at the top here, it's actually in the back. So it plugs in the back there. And if it goes in the first try, you're a pro. You're better at USB than I am. And then the other end goes into your computer. I have here a motor, which you're maybe familiar with from our winch build. And I have a sprocket on here already. Your motor that you know has a red and a black, positive and a negative. Now, when we use our Cortex to control this, what we're going to do is we're going to send the motor through an intermediary, which we call a motor controller. Now, this motor controller, what it does, its purpose is to vary the speed, to control the motor, obviously. So you can make the motor spin faster, you can make the motor spin slower, you can actually make the motor spin the opposite direction, all from the Cortex. And you'll notice that there are two wires on my motor here. And my motor controller, if you look at either end of this, there's 3 prongs here and there's 2 prongs there. My motor will plug into the motor controller, the 2 to 2, and make sure that you line up the red to red. So my red is on the bottom and my red is on the bottom, and I'm going to hook those together like this. And now I've made a connection between my motor to my motor controller. Now, you went from a 2-prong to 3 prongs. The purpose of this third prong, you'll see a red, a black, and a white. The purpose of that third one is to send data to the motor controller. So it sends different pulses, and that can tell the motor controller to turn the motor different ways. Biggest mistake I see is people forget about this. You're so used to using your motors that you just plug this right into your Cortex, and you're like, why doesn't my motor work, Mr. Hare? It's supposed to be spinning backwards. And 9 times out of 10, it's like, you forgot to hook up a motor controller. Now, when you have your 3, if you look on top of the Cortex, this is where we're going to plug. There's all these sockets over here. The sockets say, let's see if you can see, if it focuses. You'll see motors. They're over on this side. See how it says motor on the edge? And then it says digital here, and it says analog down there. I'll teach you what sensors we have, which are digital, which sensors are analog. But suffice to say, you're going to bet that your motor gets plugged in here. So I'm going to plug it into port number 2. Now, these little plugs, they only plug in one certain way. There's a little thin blade. It's hard for this to focus on it. But you can only plug it in one way. And I've plugged this in to port 2 right now. Hard for you to see, I know. Not the most ideal. But here's my motor plugged into my Cortex. Let's go over, and I'm going to show you the program that interfaces with the motor and the Cortex. Well, here we are. You probably have already built what I'm calling the test bed. So the first few days of this, I had you building right there, this thing. And this test bed is exactly what it sounds like. It's every single sensor and motor that we have in the POE program for you to test out. How do they work? What is it? There are motors, and you see these wheels hooked up so you can tell that the wheels are spinning and which way they're spinning and how fast they're spinning. This thing in the center is a servo. This red box is we call an encoder that you can spin it, and it counts how many times it spins. This is sonar, so it can tell how far away something is. This down here is a potentiometer. It's a knob, like volume. Think of a volume control. It's basically a variable resistor. So it sends a resistance, and your Cortex can read that. This is a flashlight that you can turn on and turn off. Your battery pack here. This is a light sensor, so it senses the ambient light in the room. A limit switch, that little finger. So you can put that on front of a robot, and if it hits the wall, it will depress that switch, and oh, let's go backwards. We went too far. This is a push button. You can push it with your hand. This is a line follower. You can point that straight down onto a piece of paper or the floor, and you can sense dark and light against the floor. And then here we also have the engine or the motor controllers. So servos don't need a motor controller, but your motors do. So again, the biggest mistake that I find when people working with their motors is they forget to go into a motor controller before they go into their Cortex. And if you look right here, there's a little tiny LED that you plug in. In the future, we're going to get to some of these things are digital, like your push button and the encoder. And I think that the sonar is also digital. And we'll get some of these things are what we call analog, like your potentiometer is analog. Your light sensors, those are analog. What does it mean to be digital? What does it mean to be analog? We'll get to that and why we plug them in where they do. So you just follow the instructions, which I'm sure you have, to set this bad boy up. Let's talk today about your program. How do you set up the actual program to do the interfacing? And we're going to write our first code today, me and you. So this is, I found this on the internet. Chris and Jim, God bless them. There must be a teachers somewhere, but they do computer integrated manufacturing. It's a really great step-by-step, and I'll put this on Schoology for you, how to set this up, where to click, and we're going to go through this together. So I'm just going to open it up over to the right. Step 1. Open up Robot C. What I do, I just go over to the search and I type in Robot C, R-O-B-O-T, and then usually there's a couple of them. Don't get fooled into doing this graphical one. Do the Robot C for VEX Robotics 4.x. So click on that and you're going to open up Robot C. Let's see if it opens up. I'm sure something will screw up here. This is the one thing that is a given that something's not going to work when it comes to robots. Sure enough, here's the first thing that doesn't work. And I don't think that matters. I'm just going to hit File New and File New File. I can just click this guy here, New. Yep, everything's fine. So we are good. So I'm going to make this window I'm going to open these so we can kind of see both of our instructions and our robot C here. Okay, plug in the battery to the Cortex. So I've got my battery here, got my Cortex, and you make sure it only goes in one way, so it's idiot proof, in other words. The plug is keyed, so it only goes one way, blah, blah, blah. Plug the USB-A. So I've got it plugged into my computer right now. That's step 3. It says, if you have a red and green, all right, turn on the Cortex. Believe it or not, this is another big thing. Mr. Hare, this isn't working. Is it plugged in? And is it turned on? 2 very simple questions that answer a lot of students' questions. When I turn it on, let's see what happens. It's turned on. Nothing. Okay. It says your robot is slow blink equals green. Okay. If robot LED stays red, the voltage in the battery is too low. My robot's kind of blinking red, so I don't know if you can see it from where you're at. So we will see what that means when it comes to doing anything. Let's go on. All right. Ensure that we have the correct platform. So we're going to select platform from the robot drop-down, robot platform type. It should say VEX 2.0, and it does right here. We don't, if it's this VEX IQ, nope, make sure it's VEX 2.0. And then you'll see the next one says ensure natural language. So we go platform type, natural language PLTW. You want to make sure that this is selected and the natural language PLTW is selected. And then that's good to go. Communication mode. So we want to make sure that it's communicating over USB. So we go to that same robot drop down and we're going to select VEX Cortex communication mode. So our Cortex actually has a Bluetooth, or a Wi-Fi dongle that you can plug in, and it can communicate over Wi-Fi. We're not going to use that when we use our remote controls. In a couple of weeks, you'll do that. But for right now, make sure that you select USB only. This is if we want to send code to our Cortex via the code, and then we can unplug it, untether it, and it will run the code that we've given it. Change the menu level. Select, if you go from the window, menu level, there's 3 different levels. So let me give you an idea. So when I go click view, see how I only have 3, 6, 10, I have 10 different things I can select. If I give myself an expert, now I go to view and it's oh boy, now I've got 15 things. If I go to window, menu level, and I go super user, now I've got 25 different things. So I don't know. I'm going to keep myself basic for now. If you want to go super user, there's nothing wrong. You're just going to have more choices on everything. I'm going to keep myself basic for right now. But feel free to give yourself super user. I think as we move forward, it's going to make you select super user to get some of the different cool bells and whistles. But for right now, I'm going to keep myself basic. Ensure communication. When I go from the view and I want to hit select communication port, so I want to make sure that this, oh yeah, here we go. Look at there's the Cortex. So I'm going to select this one and hit OK, just to make sure that it's there. Maybe yours says something, maybe it doesn't. We'll have to figure that out. Select open sample from the file. So I'm going to hit File, Open Sample Program. Now I don't know where this is going to inject you when you click it. But you want to make sure that you're in VEX 2. Then you're going to scroll down to PLTW. PLTW, not the PLTW natural language, but the PLTW. And then you're going to do the PLTW template. And what that is, it's just a template. You saw my task main from just a second ago. This is what they look like normally. So your file is really blank. All of your code goes in between these curly braces as we make our code. But to make it, when you do a template, it gives you you can title it intro, VEX, intro, team members, Mr. Hare, date, 11/22, section, best section. task description, I'm playing around. Pseudocode. What pseudocode is when somebody gets into your code, when you look at the code, it's really hard to tell what is going on. The pseudocode, you just write in simple English what we're going to do. We're going to turn a motor on and off. That's my pseudocode. All right. So I filled in my stuff. I'll go back here. Clear Cortex and reset the firmware. I am going to suggest that you do this. If in the future, if you run into issues, the first thing I do is it turned on? Second thing, is it plugged in? Third thing, I try plugging the USB into another port on the computer because sometimes that works. Number 4, if none of those things work, I flash the firmware, meaning I erase the Cortex and write new things. And I would suggest that you do this right off the start. So I'm going to go through this with you. So what you do is you hit Robots, Advanced Tools, and then it's, oh no, that's not it. Download firmware. And then you're going to go down to the bottom one that says Manually Update Firmware. And then you do the top one that says Robot C, and then you're going to do the standard VEX Cortex. I've talked with tech support at VEX multiple times, and this is one of the things they always have me do. If I have any issues, like I don't know what's going on, this is one of the things that I do, is I re-flash the firmware and then re-send my code to it. So it's pretty safe. This takes about 10 seconds. Oh, it's successful. That is good. The next thing is you do it again. File, download firmware, manually update firmware. Now you do the second one, master CPU firmware. We just did the Robot C firmware. Now we're going to do the master CPU and do the standard file. This one may take a few more seconds, but tech support always has me do those two things when I have something going on with my VEX. So you may have to do this. In fact, I would encourage you to do it right away to just make sure this thing is in good working order. And as this is working, everything from here on down on this document, it says VEX troubleshooting. So you're ready to rock and roll at this point once we get here. And we'll do our first code just so you can kind of see, hey, success, everything is good. Now, let me take you through actually writing a code for you. So what I'm going to do, I'm going to take a motor. And remember to plug your motor into a motor controller. And also take care to go red wire to red wire when you're doing this stuff. And then my motor, I'm going to, on the top of the Cortex, you'll see a bunch of ports. I'm going to plug mine into, some of these ports are labeled motor. So I'm going to plug mine into port number 2. So I've got a motor plugged into port number 2. So now, let me show you how you write a little code here. Fling over here. First thing we have to do is we have to tell the Cortex what is plugged in. So we're going to go robot, let's see here. Motor and sensors setup. So we're going to click here. And in port number 2, remember how I told you I had motor? So I'm just going to call it, you can name it anything that you want. I'm going to call it hair motor. And then you have to tell it what type. This is written on it. It says a 393 motor. So I'm going to go down here to 393. No, I don't think we have the high speed or turbo high speed motors. So just 393 motor. If you want to reverse it, you can either A, flip the chords around, or B, you can select that little box and that will automatically reverse it. So I'm just going to leave it as is. There's no encoder built into this. Drive motor side, you can name that if you want. I don't ever do anything with that. So I'm going to hit OK. Now, do you see that this line popped up here in my code? This is declaring, it says what's happening. If you guys ever have any experience with an Arduino, it does the exact same thing. That I'm configuring a motor into port 2. I have named it hair motor, and this is the type of motor it is in an open loop. I don't know exactly what that means. So what I'm going to do over here, inside my task main, So I have my name and stuff here. You'll see that it's green. I'm going to do this. Check this out. There's a few commands I'll teach you here. Start motor. So if I hit start, I can hit start motor, or I can just hit enter. Or you can, I got to name it. Which motor do I want to start? Hair motor. And then you tell it what speed. Let's hit 30. Let's see what that means. And then you have to end every line with a semicolon, and then you hit enter. The other thing you can do is you can come over here and you can go to motors, and I wanna start it, and I'm gonna wait for I don't know, 3 seconds. So I think timing commands. So yeah, wait. There's a wait one. Variables. You can find all the different. I'm just gonna hit wait. And I think if you go super user, you'll give yourself way more of these. So I'm just gonna type in wait 5, because I think 5 equals 5 seconds. If not, I can change the code. Sometimes this is in milliseconds, so we'll find out. And then I want to stop my motor. So I think, let's see if I can figure out how to do this. Motors. Yeah, I'm going to make myself a super user once and see what that does. I got way more now. Motors. Variables. It doesn't even, there's no stop motor. That's okay. Maybe it's under something else. Nah, whatever. I'm just going to type stop motor. And you'll see stop motor. Which motor do you want to stop? We'll do hair, motor, comma. Well, I think you just got to tell it to stop that motor. And then I'm gonna start it for 1 more second. Nah, whatever. We'll run this. So then here's my code, and what we're gonna do is we're gonna comment this code. So you hit forward, and this is telling the people what's going on. I'm starting the motor. Waiting 5 seconds. Stopping the motor. Now I hit robot. Compile and download. So it's going to check this for errors. First we have to save it. So I think I'm going to save it in my desktop. Trial 1. Whatever, I don't know. I thought I saved it, but okay. So now it's sending it to the Cortex. And so let's see. I'm going to hit the start button, and we'll see what happens. Oh, man. Oh, there it goes. For some reason, I don't know. Start. 1, 2, 3, 4, 5. Stops. Cool. And if I hit that start button again, 1, 2, 3, 4, 5. Hey, that's cool. So I'm going to copy this. I'm going to put a wait here. I'm telling you, one wrong move inside this code, and it won't work. Look for the things to change color. That's a hint. So I'm just going to turn it on, turn it off, turn it on, turn it off, turn it off. So let's send this to it. Compile and download program. So you can quickly change the variables inside your robot. And let's start this and see what happens. Very nice. Let's run it again. Oh, yes. Oh, yes. Very fun. Welcome to Robotics, kids. I promise you, yours won't work. I make you this promise. Mr. Hare, mine's not working. it will be something that you say almost on a minute-by-minute basis. And because I'm not with you, I'm going to need you to work at the issue. It could be a hardware issue. Maybe you plugged this in to the wrong port. Maybe you plugged it, maybe it doesn't have a solid connection. Maybe the motor just doesn't work. It could be a software issue. You change this to a semicolon. If I just did a regular colon, and then I robot compile and download this, it's going to give me an error, I think. Well, maybe not. What do you know? Maybe it's a software issue. There are so many things that it could be. Is it plugged in? Is it turned on? Have you flashed your memory? Have you put the USB into the other one? Have you looked through your code? Have you double checked that you have everything in there? I can't be there with you to go through all of your issues. Google the problem. If you've tried everything, that's what I'm going to do. You can call tech support. Like, call VEX and say, hey, I'm having an issue. Can you help me troubleshoot that this isn't working? If you've gone through everything else, there's lots of things that you can do. And I'm going to really need you to work hard to try to solve your problems on your own when you're not with me. All right, friends. We'll see you on the other side.